Good morning, everyone. Kaudini, can I do it? Who is there? Kaudu ikmikina bangan namadan. Right. I gave a long question for homework, and it's from this we are starting applied maths standard projectiles. Right. The questions I gave earlier matching more to the physics level. Right. So from today we are starting. So we have discussed all the basics in like numbers. Now today more the the applied maths we are starting things. Right. Anyway, the question there are many parts. First part A, under A there are several parts as I remember. Uh, First to find the maximum height. You are given particle is projected at speed u at some inclination alpha with the horizontal. First to find the maximum height. Uh, to find the maximum height, part one, A to C motion. I'm just working this out for you to check your answers, right? You should have done this for homework, not anything that hard. Upwards to find the maximum height, we apply v squared plus u square plus 2as upwards d0 at c. At the beginning, it is u sine alpha and square of that minus 2gh. It is the height that we need to find. Uh, Good morning, Satin. So h is equal to u squared sine squared alpha over 2g. This is the answer for the first part. The second part, you have to find the time to reach the maximum height. Again, we have to apply the formula from A to C motion upwards to find the time for the maximum height. Find t. So we will apply v equals u plus at. V is 0, u is u sine alpha, minus dt. So this gives t equals uh, t equals u sin alpha over g. U sin alpha over g. So that's the answer for part two. Then you have to find the total time, the flying time. Then the particle takes to travel from A to B for the total motion. So we apply for from A to B to find the flying time. We use the fact that when you consider the motion from A to B, the full motion, the upward displacement, vertical displacement is none. So we can use that fact. Taking vertically, S is 0. So to use that, apply vertically upwards. S equals ut plus half at square. So S is 0, u sin alpha t minus do2 t square. T will get cancelled. Same t. Don't forget to write t is not equal to 0 when you divide like this. So that you t equals 2u sin alpha over g. This is the flying time, right? Next part is to find r, the horizontal displacement. Again, you have to apply from A to B, part 4. A to B motion to find horizontal displacement. Only one formula we use horizontally, that is S equals ut. Horizontally, S equals ut. S is r, u is u first alpha. T we found a moment ago. It is 2u sin alpha over g. So we see like u square is there. I'll take it out. To front. U square over g. Then you see 2 sin alpha cos alpha. I write it here. 2 sin alpha cos alpha. So usually we don't leave it like this. 2 sin alpha cos alpha. Instead, you should within a plan should come into your mind. This can be replaced by sin 2 alpha. Right here. U squared over g sin 2 alpha. Right? U squared over g sin 2 alpha. That's part 4. Then part 5. This is our part 5. You have to find height and velocity when the horizontal displacement is r over 5. When the particle is at a horizontal distance. When the horizontal distance displacement is r over 5, you have to find the height, say y, and the velocity. As the velocity, we will find the two components, then the resultant with magnitude and direction. That's how we give the answer. So, as the horizontal displacement is r over 5, that's part 5. When this direction displacement is r over 5. So we can use this. Like, there are three things to find: the height, vertical displacement y, and the components. Vx and components of velocity Vx and Vy. Uh, Anything you can find very easily if you know the time. If we have the time t, so you can easily find the other things. So how to find the time? To find the time t, the data is horizontal displacement r over 5. So we can use that to find the time. We'll first find time t, then use that to find the other things. Mhm. So to find the time t, use that horizontal displacement r over 5. Horizontally, the only formula we use is equals ut. We'll use that r over 5. R over 5 equals u cos alpha t. So t is for r we can substitute. For r we can substitute either from this u squared over g sine 2 alpha, or there's another option u squared over g 2 sine alpha cos alpha. So which is better here? To use sine 2 alpha or 2 sine alpha cos alpha? Hmm? On the other side, you have u cos alpha. So if you apply this for r, so things will get simplified. So better we use this. Hmm? So r is u squared over 5 taken with this r over 5. Then u squared over 5g 2 sine alpha cos alpha. On the other side, you see u cos alpha t. U cos alpha t. So cos alpha will get cancelled. So u, and we get the time taken by the particle to travel is that horizontal distance is 2u sine alpha over 5g. This is the time taken by the particle, right? 2u sine alpha over 5g. So now we have t, so you can find anything. The first to find the vertical displacement. So we have t, need to find y. So upwards we can apply s equals ut plus half at squared. Hmm? Upwards applying s equals ut plus half at squared. X is y, u is u sine alpha, t is this 2u sine alpha over 5g minus g over 2 t squared. T squared will be uh, minus g over 2 t squared will be 4u squared sine squared alpha over 25 g squared. Things will get simplified. We can see that the g get cancelled. So in this 2, yeah, you can simplify it a bit. හරි අඩුපාඩු තියෙනවා නම් හදාගන්න මම පොඩ්ඩක් කරලා දෙන්න. මට බැයිද මදි ඉතුරු ටික. ඔය ටික කරගෙන යන්න. Simplifying. I plus you get, you can take u squared sine squared alpha. 2 is also common over g 5g. You can take 5g out. That'll give, so with the whole thing taken out, that'll give 1 minus 1 minus 1 minus 1. Okay. 1 minus 105. So it looks like u squared sine squared over 5g taken out. So it's also then 1 minus 105. Yeah, so it is 4 into, that's like 8 u squared sine squared alpha over 25g. This is the height. నేను రైల్లో తిరిగి సెకండ్ for the height. Okay, next you have to find the velocity. To find the velocity of the particle, we need these two components, Vx and Vy. So in fact, there is nothing defined of Vx. Vx is always it's maintained, the horizontal component of velocity. Then velocity, I'm going to find velocity. Horizontal component, it remains the initial one, it is u cos alpha because there is no acceleration in that direction. And find the vertical one, we have to apply the formula. So let's apply v equals u plus vt, vy equals then u sine alpha minus gt. T is here, t is here, t is this 2u sine alpha over 5g. So it's altogether 3u sine g and g cancel, get cancelled. 3u sine alpha over 5. That's the vertical component of velocity. So we have the horizontal component and also the vertical component. Now you can use them to get the resultant velocity with both magnitude and direction. We'll find. So let's find the resultant of these two components. In this direction, u cos alpha. Upwards, 3u sine alpha over 5. So let's mark the resultant. Some v with inclination not alpha, v some theta. Then magnitude of the velocity is equal to square root of I will just use it 9u squared sine squared alpha over 25 plus this is u squared cos squared alpha. So we can take u squared and 25 out, so that will come out as u over 5 with the square root. Remaining 9 sine squared alpha plus 25 cos squared alpha. So u over 5 square root of 9 sine squared alpha plus 25 cos squared alpha. This is what we get for the moment. You can simplify it a bit. 9 sine squared plus 25 cos squared. So we can take a 9 cos squared. Out of this 25, we can take 9 together with this. That will give 9 sin squared plus cos squared alpha. That will be equal to 9 into 1 plus then a 16 of cos squared alpha will remain here. 16 cos squared alpha. So that's the magnitude of the velocity. Then the direction, theta is given by tan inverse of 3u sin alpha over 5 divided by u cos alpha. U get cancelled. That is tan inverse 3 tan alpha over 5. 3 tan alpha over 5. Right? So this is the final answer for part 4. Part 5 rather. There's a part 6 also. Part 6. Part 6 and part A, right? There you are given the vertical component of velocity. At some instance, the vertical component of velocity is half the initial vertical component. So that's the question, right? That's the data. When the vertical component of velocity is half the initial vertical component, then you have to find the position of the particle. When Vy equals half of the initial component, that's u sin alpha. This is the data. Again, if you can find time t, now we need the position, right? To find the position, it's easy to find time t. With t, you can find the horizontal displacement, vertical displacement. Anything you can find easily. Right, this is the data, vertical component. To find the time t, we will apply vertically v equals to plus 80. Upwards, v equals to plus 80. So v is u sin alpha over 2 equals u. Initial velocity is u sin alpha minus dt. Minus dt. So this gives Mathematica d equals Mathematica u sin alpha over 2g. This is the time taken by the particle when its vertical component of velocity is half the initial one. Now we have t, so we can use this to find the horizontal and vertical displacements. So to find the horizontal one, apply in this direction s equals ut, s is some x, u is u cos alpha into t. T is u sin alpha over 2g. So it's u squared sin alpha cos alpha over 2g. So that's the horizontal displacement. Horizontal displacement. To find the vertical one, you have to find the position, right? So you have to give both the horizontal and vertical displacement. To find the vertical one, we will apply upwards. You know time t, need to find the vertical displacement, so we can use s equals ut plus half at squared. S is some y, u is u sin alpha, s is some y, u is u sin alpha, T is this මෙතන මට ඉඳ මදි වෙන්නේ. හරි. ඔය ටික අඩුපාඩු තියෙනවා නම් හදාගන්න මට මෙතන ඉතුරු ටික ටික මදි. මම පොඩක් කියලා දෙන්න. වැඩි අඩුපාඩු තියෙනවා හදාගන්න. So to find the vertical displacement, so let's apply upwards this and we put it. S is become y, u is u sine alpha, t is this, minus go2, go2 t square, square of this, so that is equal to u squared sine squared alpha over 4g squared. G will get cancelled. Uh, you can take u squared out, sine squared alpha out, and also I take 2g or maybe 8g. So then that will be 4 minus 1. So the height is 3u squared sine squared alpha over 8g. That's the height. So that's the answer for the part. We found the horizontal displacement and also the vertical displacement. It's better if you write it in words. The particle is, we write it in words. The particle is at the horizontal distance The horizontal distance u squared sin alpha cos alpha over 2g from A, and at a height, this is the height, 3u squared over 3u squared sin squared alpha over 8g at this much of height above the ground. It's better you write it in words. The answer. So that's the complete answer for part A. There are 6 parts on part A. We worked out all. So first take it down, then we can go to part B. Harinendra, right. Right. Shall we go to part B? The part B, read the question in part B. Mang open part A tamai haritum karana tuju. Part B kami tinang karana kila tuju. Part B and part C. I told you it's optional. Part A, the 6 parts of part A I told you to do. Okay. Now part B. Read the question. Right. Part B. Now part B and in C also. Much about this horizontal displacement, B and C. Right. There are more things to speak about. Uh, the horizontal displacement R. right? That's what we are going to do in part B and C. These are also in B and C. These are also some theory, right? Things you should know by heart, right? Uh, in this section, the things you should learn. Uh, so part B is about the maximum of R. What is the maximum value of R, and what is the angle alpha which maximize this R? So that's the question in part B. So okay. So we have an expression for R, right? So we will use it an expression for R by we found an expression for R in about part A and 4, right? Part A4 by about A4 A4 we have R equals U squared of gila බලන්න එතන part A, fourth part of A, right? So we found that R equals U squared over G sine 2 alpha. We found this earlier, right? Now the question is about the maximum of R. So if you look at this, so R is equal to this. Here U is given some given velocity, right? U is some given velocity. So it's constant. U squared is constant. G is the gravitational acceleration. It's invariant, so that is also constant. So as a whole, this part U squared over G is a constant, right? So R varies with sine 2 alpha part. R varies with sine 2 alpha. Moreover, R varies with alpha. Because sine 2 alpha varies with alpha, right? So R is maximum or minimum is determined by whether sine 2 alpha is maximum or minimum. R varies with sine 2 alpha, in short. So we want to find the maximum of R, and we know that in this U squared over G is constant. U squared over G is a constant, therefore, and sine 2 alpha varies. It varies between. Now remember that we are in applied maths, right? This is not the pure maths lesson. So theoretically, sine 2 alpha can fall in the range from -1 to +1, right? From -1 to +1, that's theoretically, but this is applied maths, more practical things we are talking about. Uh, sine 2 alpha, basically alpha. This alpha should be, if you want to project it at this point A to fall somewhere here, so no point of giving a velocity in this direction. මෙහෙට වැටෙන්න ඕන එක මෙහෙට විසි කළා හරියන්නේ නැහැ නේ ළමයි. Right? So so theoretically, practically, whatever it's theoretically, practically, this alpha should be between. If you want to see the particle projecting moving this way, so you have to project it between 0 and pi by 2, right? Practically, this alpha has to be between 0 and pi by 2. So sine 2 alpha should be between 0 and pi. First or the second quadrant. In these two quadrants, sine is positive. So no negative possible values for sine 2 alpha. Okay, the sine 2 alpha has to be positive because alpha is between 0 and pi by 2, and 2 alpha is between 0 and pi. Okay, so sine 2 alpha cannot be negative. negative values you get in the third or fourth quadrant. So this cannot be negative. It should stay between 0 and 1. 0 and 1. So the minimum value is given when sine 2 alpha is equal to 0. Maximum is given when 1. Uh, minimum value is given. ඔකට ගණන් හදන්න ඕනේ පොඩි ළමයිගෙන් අහුවත් කියන්නේ. Minimum value is when sine 2 alpha is 0. That's r equals 0. R equals 0 minimum value. Give it a number. Everybody knows that. පොඩි ළමයිගෙන් අහුවත් කියන්නේ. That's when you project it at 90 degrees. Right? Sine 90 is 0. Sorry. Sine 2 alpha. Yeah, sine 2 alpha is 0 when alpha is 90 degrees. But you project it right upwards, it will fall right back to the, it will come right back to the starting position. Okay, so sine 2 alpha is between 0 and 1. Therefore, so sine 2 alpha maximum value is equal to 1. Therefore, R max sine 2 alpha max equals 1. Therefore, R max is u squared over g. This is the maximum possible value of R, right? And then you have to find the angle at which R is maximum. So we know that R is maximum when sine 2 alpha equals 1. Sine 2 alpha equals 1. That is 2 alpha equals 5 by 2. That is alpha equals 5 by 4. 5 by 4. This is the angle. 5 by 4 is the angle which gives maximum of R. So to project it to a maximum horizontal distance, to see that it's falling at the maximum horizontal distance, so you have to project it at 5 by 4, 45 degrees angle, right? දැනට ඔක ලියාගන්න. ඔක කොහොමද සමාන පිසිස් පන්තියේදී ඔය විදිහට මිගෙනගෙන ඇති. ඔකම ලියාගෙන ළමයි පිසිස් පන්තියේදීත් ඉගෙනගෙන ඇති. ඒ වුණාට මේකේ අපිට තව කතාරන් දේවල් තියෙනවා. පිසිස් පන්තිය ඉගෙන ගත්ත විදිහට නිකම්ම කටපාඩම් කරන්න බෑ. We are discussing it with more details. First, you take it down, then we will see what are the other things to discuss. Explain here. Hari, now like we found out that uh, you projected the particle at 45 degrees, it will fall at the maximum distance, horizontal distance, right? Now, knowing this, say practically where do you apply this? Like, kind of go, I then ඉස්කෝලේ පටන් ගත්තා කියලා පෙබරවාරි මාර්තු මාසෙලයි පටන් ගත්තම මම දන්නේ මේ සැරේ කොහොමද කියන්නේ වෙනදට නම් ඉස්සෙල්ලාම තියන්නේ අලුත් අවුරුද්දේ ස්පෝර්ට්ස් මීට්ස් තියනවා නේ ස්පෝර්ට්ස් මීට්ස් වලට යනකොට දැන් ඔන්න ලබන අවුරුද්දේ ස්පෝර්ට්ස් මීට් කාලේ දැන් මොන ආර්ට්ස් ක්ලාස් එකේ යාළුවෙක් යනවා හොඳ උස මහත තියෙන කෙනෙක් යනවා මොනවද පක්ෂප් එක දාන්න යාළුවෙක් දැන් ඉවල ගිහලා යාළුවාට දෙන්න පුළුවන් ඇඩ්වයිස් එකක් ඔයාට මේ දිනන්න ඕන නම් right if you want to see it's falling at the maximum distance we learned these things in the maths class for applied maths right if you want to win you just project it at 45 degrees යාළුවට එහෙම උපදෙසක් දෙනවද මොකද කියන්නේ දිනන්න ඕන නම් අපි මේ ඉගෙනගෙන තින්නේ මැත්ස් පන්තියේ අපි මේ හොඳට ගන්නවා ඔයාලට දිනන්න ඕන නම් මේක අල්ලලා අන්සර් 45 විසි කරන්න යාළුවට එහෙම උපදෙසක් දෙනවද එහෙම නැත්නම් අර මොනවද ඩිස්කස් එක දාන එක්කනට ඔයාලට දිනන්න ඕන නම් මේක විසි කරන්න අන්සර් 45 ජැවලින් එක දාන්න යාළුවට කියනවා එහෙම නැත්නම් දුර පයින් එක්කනට දුර පයින් යාළුවට කියලා කියනවා දිනන්න ඕන නම් ඇවිල්ලා අන්සර් 45න් පනින්න මොකද මේවා අපි ඉගෙනගෙන තියෙන මැත්ස් පන්තියේ right මොකද කියන්නේ එහෙම උපදෙසක් දෙනවද යාළුවට ආර්ට්ස් පන්තියේ කවුද ඉන්නේ සචින් ඉන්නවා කවුද ඉන්නේ කොහර දෙන්නයිද කොහෙද ඉන්නේ දැන් උඹලා ඉන්නවා මම දන්නේ නැහැ මොකද කියලා අනිත් අය පස්සේ බලන බව මම දන්නවා ඒ වුණාට මම හැමදාම කියන්නේ කීප දෙනෙක් ක්ලාස් එකේ ඉන්න එකයි හොඳ මට දැන් කාත් එක්කද මම කතා කරන්නේ නැත්තම් නේද එහෙම ප්‍රශ්නයක් තියෙනවා ඔක්කොම ඕනේ ප්‍රශ්න තියෙන මොනාරි වෙන වැඩ තියෙන වෙන ක්ලාසස් එහෙම තියෙන අය පස්සේ බැලුවට කමන්නේ අඩු ගානේ 5-6 දෙනෙක්වත් හිටියනම් තමයි හොඳ මම ප්‍රශ්නයක් වත්තාන්න කාගෙන්ද නේද නැත්තම් මොකද කියන්නේ දැන් මේ ආර්ට්ස් පන්ති යාළුවට එහෙම උපදෙසක් දෙනවද ස්පෝර්ට් මීට් එකට දවසේ උදේ ගිහිල්ලා දුර පයින් එක්කනට පයින්න දැන් තරගේ පටන් ගන්න ටිකක් වෙලා තියෙද්දි අට දිනන්න ඕන නම් පයින්න අන්සර් 45න් එහෙම තමයි අපි ඉගෙනගෙන තියෙන්නේ මොකද කියන්නේ අපි මේ ඉගෙන ගත්ත තියරි එක ඇප්ලයි වෙන්නේ. එහෙමද? එහෙම දෙනවා උපදේශක්. ඕම උපදේශක් දුන්නොත් තරඟ ඉවරුනාම යාළුවා ඇවිල්ලා අර මොකද්ද පට් ෂොට් එක ඇවිල්ලා ඔලුවට අතාරි. නැත්තම් කකුල් දෙකට අතාරි. පැරදුනාන් පස්සේ. මොකද there is a problem here, right? Of what we learn here and the practical situations here. This is something you should understand very well. So we have some result. So we are saying if you project it at 45 degrees, then it will reach the maximum distance. But this thing, whatever result you obtain in mathematics, mechanics, right? Or everywhere in physics, chemistry, it's valid only under the circumstances, the conditions, only under the conditions under which you are obtaining the result. If you obtain some result under some conditions, you can apply it only in that conditions. If the conditions are not met, violated, right, you can't apply it, apply the theory that you have. Physics පන්තියේ chemistry පන්තියේ හරි ඉගෙන ගත්ත එකක් තියෙනවා නම් the temperature has to be, you derive something, that temperature has to be between 10 and 25 degrees. එහෙම එකක් ඉගෙනගෙන can you apply it for 50 degrees then of Celsius? If you have 45 degrees, yes, let's see. If you obtain something, say නිකයි කරන පරීක්ෂණයක් කරනවා, some experiment, මොනවාද ඔයගොල්ලෝ කියන්නේ මට physics කියන වචනයක් මතක the normal conditions, මේ දැන් තියෙන පරිසර තත්ත්වයටනේ කරනවා මේ මොකද කියන්නේ around 25-30 degrees of centigrade and at atmospheric pressure. එතකොට එහෙම හොයාගත්ත දෙයක් can you apply at say 50 degrees? Can you just say do and see? That means you haven't tested it under at 50 degrees or 100 degrees. You have carried out the experiment at the normal, say, room temperature. So you can't say the same result is valid at 100 degrees. So similarly here we are obtaining this result under some conditions, what we are seeing here. So if you apply this result, the conditions should be the same. So what are the conditions? Any difference between this and that those examples I have taken, throwing the part shot or jumping the long jump? Can you model the long jump to this? Can you model the part shot with this, or the javelin throw? Can you model with this? Are there differences? Now carefully, listen this carefully. Right. Take a long jumper. Long jumper. Long jumper means here we have derived this result for just a velocity u at some angle alpha. The particle has only this velocity u at some angle alpha, right? Some velocity u at angle alpha. The මේ මනුස්සයා පනින මොනවාද අපේ long jump ක්‍රීඩකයා ක්‍රීඩිකාවක් වෙන්න පුළුවන් නැත්නම් සමහර තරගේ මොනවාද running at jumping at 45 degrees at that board, 40 some angle alpha. එතකොට ඒක විතරද තියෙන්නේ. So you have only this velocity. There's no other component. Then get back එහෙම පයින්නවා නම් මේ ඕම හිටියා ඕම වෙන්න. දැන් දුර පයින් එක්කෙනා long jumper දුර පයින් එක්කෙනෙක් ගත්තොත් long jumper කෙනෙක් ගෙම්බෙක් වගේ ඉන්න තැන ඉඳන් ජබුක් ගාලා පයින්නවද? හ්ම් නෑනේ. ඔයගොල්ලෝ දැකලා ඇතිනේ. ඔයගොල්ලෝ පැනලත් ඇති. You now you run in to the board. What do you call it? අතන තියෙන පයින් බෝඩ් එක නේද? මාක් එකට. as fast as possible. මම කඩාගෙන දුවගෙන ඇවිල්ලානේ පයින්නේ. නිකන් ගෙම්බා වගේ හිටපු තැන ඉඳන් පයින්නේ නෑනේ. Why is that? Is there any use of that? Running in, just wasting your energy. පණ දාගෙන හති දාගෙන දුවගෙන ඇවිල්ලා පයින්නේ. නිකම්ම පයින්න බැරිද ගෙම්බා වගේ? මොනවාරි හේතුවක් තියෙනවද? මාන්සෙලා දුවගෙන මේකේ. ප්‍රයෝජනයක් තියෙනවද? ප්‍රයෝජනයක් තියෙනවා. ප්‍රයෝජනයක් තියෙන නිසා තමයි එහෙම කරන්නේ. ෆාස්ට් බෝල්ස් ලා ඔයගොල්ලෝ දැකලා ඇති. පණ කඩාගෙන දුවගෙන යනවා නේ. මොකක්ද අර? බස් එකේ යනවා නම් මේ රුපියල් 12 ටිකට් එක විතර දුර දුවගෙන යනවා සමහර ෆාස්ට් බෝල්ස් ලා. මේ ඕරක දාලි වෙනකොට කොහරි මේ විමාන කමින් නම් රුපියල් ටික දුර දුවලා. ඇයි ඒ? ප්‍රයෝජනයක් තියෙනවා. මොකක්ද දන්නවද? මෙහෙම දුවගෙන ඇවිල්ලා පට් ෂොට් එක දාන එක වට කැරකිලා ඔළුව කැරකිලා යනකම් නේද? මට දෙතුනක් කැරකිලා යන තමයි විසි කරන්නේ. So what do you do there? Right? Taking a long jumper, for instance, runs into the boat before taking off. Right? එතකොට මෙහෙම following උඩට යන්න හදනකොට due to the jump, the jumper has some velocity at some inclination with the horizontal due to the jump. But together with that, due to the run, some component will, some speed will remain in the horizontal direction also. මෙහෙම පැන්නට අර දුවගෙන ආපු එකෙන් මේකට තව velocity එකක් ඉතුරු වෙනවා. This will not be the only velocity for the long jumper. In addition to this, he or she, right, will experience another velocity component in the horizontal direction. So, the conditions are different to this. කාලතෝක්කකින් වෙඩි තියනකොට දැකලා ඇති. නැත්නම් මේ පන්තිවල නම් වීඩියෝ එකක් කරන් බලන්න. කාලතෝක්කකින් වෙඩි තියනකොට මෙහෙට වෙඩි තියනකොට තොක්කෝ මෙහෙට ගැස්සෙනවා. එතකොට අපි තොක්ක ඔපරේට් කරන මිනිහට ගිහිල්ලා කියන්න පුළුවන් දුරම තැනකට උඩේ වැටෙන්න නම්. So you have to keep the barrel at 45 degrees, barrel of the gun. එහෙම කියන්න බෑ. මොකද මේක වෙඩි තියනකොට මෙහෙම ගැස්සෙනවා. So there is another velocity. In addition to the velocity given by the gun, it experiences another velocity right backwards, horizontally backwards. So the conditions are different. The result will not be valid. Got that? So the first condition is the particle can have only this velocity u at inclination alpha. There can't be any other. That's one condition. This is to be valid, right? In order to get this result, 45 degrees for the maximum horizontal displacement, we need condition number one, only one velocity, only the velocity u at inclination alpha. There can be no other velocity. Okay, there's another condition, number two. Here we have obtained this result considering projectile at a horizontal level. A and B are at the same level. So this is to be valid. The projectile has to be at the same horizontal level. So again, going back to that, දුරපයින් එක්කන නම් අවුලක් නැහැ. Long jumper එකම horizontal level එකේ පයින්නේ නේ. උඩින් පල්ලෙන් හරි පල්ලෙන් උඩට හරි පයින්නේ නැහැ. ඒක මම දන්නේ ස්කූලේ යන කාලේදී ඔයාලා ගැඹුරු නම් එහෙම වෙන්න පුළුවන්. නැත්නම් at the same horizontal level. එතකොට but what about the throwing the pot shot? Pot shot එක උඩින් පල්ලෙන් බිමිනම් මෙහෙම දාන්නේ නැහැ නේද? බඩ ගාගෙන රග පොලිස් එකත් වගේ pot shot එක එහෙම දාන්නේ නැහැ නේ. උඩින් දාන්නේ. javelin එක උඩින් අඳාන්නේ. At two different levels. මෙහෙම උඩින් නම් විසි කරනවා ඊට පොළොවට වැටෙන්නේ at a lower level, right? From a higher level to a lower level. So not in the same horizontal plane, right? On the plane එක කරා යනනේ. එනවද කට්ටිය? දැන් ওই plane කාලයක් තිබුණානේ අපේ රටේ මේ අර LTT කාලේ. පස්තාවදී plane තිබුණානේ. උඹලට රටේ බෝම්බ දාලා යනවා. මොනවා යම් කරනවා හයි කරලා තිබුණා anti-aircraft guns. හිටපු ගමන් දැයට එනවා පට ගාලා anti-aircraft guns වලින් වෙඩි තියනවා, right? දැන් මොකද වෙන්නේ? දැන් ගන්න එක හයි කරලා තියනවා නම් අපිට ඕනේ මොනවද සතුරා ගුවන් යානයේට පුළුවන් තරම් දුරදී වෙඩි තියන්නනේ ළඟට එන්න නොදී පුළුවන් තරම් දුරදී වෙඩි වදින විදිහට තියන්න ඕන. ඒතකොට අපි ගිහිල්ලා මේ අර ගන්න එක ඔපරේට් කරන මනුස්සයට ගන්න එක ඔපරේට් කරන මනුස්සයට ගිහිල්ලා උපදෙස් දෙනවලු මෙන්න මේවා අපි පන්තියේදී ඉගෙන ගත්තා. මැට් පන්තියේදී වැඩිම දුරකදී සතුරු යානයට වෙඩි තියන්න ඕන නම් you have to keep the barrel at fix the barrel at 45 degrees. 45 degrees, so you will be able to hit the enemy plane aircraft at the maximum horizontal distance. එහෙම කියන්න පුළුවන්ද? එහෙම කියන්න නම් ප්ලේන් එක එන්න ඕන පොළොව දිගේ බඩ ගාගෙන. ප්ලේන් එක ඉන්නේ උඩින්නේ. So not the same horizontal. Now firing a bullet from an anti-aircraft gun targeting an aeroplane is not the situation that we see here. Not the same horizontal plane. So in that also, this theory is not valid, right? So there are two conditions that there are two conditions only under which only you can apply this 45 degrees the maximum distance. It's valid only under two conditions. Condition number one, the particle can have only one velocity, that's at some inclination alpha with the horizontal. Number two, that there can't be any other velocity, right? Number two, the projectile has to be in the same horizontal level. ඔක තේරෙනවද? ඉන්න අයට සකින් විතරයි උත්තර දෙන්නේ නේද? ඔක තේරෙනවද ළමයෝ? ෆිසික්ස් පන්තිදී නිකම්ම කටපාඩම් කරන්නේ නැති, but not in the maths class. You should realize it under only some conditions. කාරණේ පැහැදිලිද? කාරණා දෙකක් ඇත්තටම. Now we are going to write it down. දැන් ඊට පස්සේ මේ මොනවද දුර පයින් යාළුවට උපදෙස් දෙන්න යන්න එපා. To jump at 45 degrees to win the event. So let's write it down, the conditions under which this is valid. Right, we'll write note. Note. මේක අධිකර ලියන්න වෙනවා. with examples also. මම ලියන්න ඔබ copy කරගන්න. The above result is valid only under two conditions. Condition number one, the particle can have only one velocity, one initial velocity u at inclination alpha, but no other velocity component. Right, so let's explain it. For instance, for instance, a long jumper, a long jumper uh, as he takes off from the ground, experiences a horizontal velocity component horizontal component due to the run, right? Aneh, camera ka udah kari tunggu kari mau kari orang. Right. Uh, Horizontal velocity component uh, due to this run, in addition to to the inclined velocity, uh, to the velocity inclined to the horizontal due to this jump. So one cannot conclude that he gets a maximum jump, a maximum horizontal distance jumping at 45 degrees. So condition number two, the projectile has to be in a horizontal plane. For instance, if an anti-aircraft gun, anti-aircraft, if an anti-aircraft gun fires a bullet from ground level targeting an enemy aircraft flying at some height, one cannot say the bullet one cannot say the bullet has to be fired at 45 degrees in order to hit the plane, hit the aircraft at a maximum horizontal distance. හරි ඕක ලියාගන්නකෝ ඔන්න අපි කටින් ගේම් ටික ලිව්වා නෝට් එක ඕනේ ඕක ලියාගන්න ඊට පස්සේ අපි පාර්ට් C වලට යනවා යාගෙන ඉවරද? තාම කාටයක් කළා දෙන්න යාගෙන. Hari. Then part, this is the answer for part B, right? Part B with all the explanation details. Then part C, that's also theory. Right, part C. Now read part C. Part C is again about the horizontal range. It's about the horizontal range. This time we have to prove that u is given, r is given, u is given, r is given, then to fall at the same position, same point, the particle to reach the same point B, you have to show that this alpha has two values, two angles. So you have some speed, you want to throw it to a certain point. Now we are going to show, we are asked to show that there are two angles possible. So you are projecting at the same speed, the particle will reach the same point. Hmm? Uh, that means alpha has two distinct values. That's what we are going to prove in part C. That's the theory part. So we do so. Again, we have some expression for R. We have some expression for R. We are going to use that in above A4. So we have, by above A4, we have an expression for R which says it's equal to u square over g sine 2 alpha. U square over g sine 2 alpha. We'll make, so it's about the angle, right? So we'll make this the subject. This is sine 2 alpha equals g r over u square, right? This is some proof I'm writing of some theory part. U square, say it's number one. Now look at the right hand side, g r over u square. In this g r u square, everything is positive. So as a whole, this is positive. G r over u square, definitely positive, right? And moreover, in the question, see in the question you are given r is less than u square over g. It's given r is less than u square over g. So taking distance to the other side, g r over u square. So this implies g r over u square So that implies g r over u square. When you take this term to the other side, only one remains. This is less than 1. So now we have this part. We first said it is positive. Now we are saying it is less than 1. So finally, this whole thing is between 0 and 1. Therefore, therefore, altogether gr over u square is between 0 and 1, right? So this thing is between 0 and 1. If you have some number between 0 and 1, so you can for any lambda between 0 and 1, you can find some angle, say beta, such that sine beta equals lambda. For anything between 0 and 1, you can find some angle such that sine beta equals lambda, or not only between 0 and 1, for anything between -1 and +1, or -1 and +1, you can find some angle sine of which the sine value is equal to lambda, right? So this thing is between 0 and 1, so we can replace it by some beta, because this is between 0 and 1, beta has to be an acute angle in the first quadrant. Therefore, we can find an angle alpha, angle beta between 0 and pi by 2, such that sine beta is equal to gr over u square. This part is equal to sine beta. Now by 1. Again, remember we are in applied maths, right? Not in pure maths. More practicable things under the practical conditions, practical limitations, conditions. We have this, not the theoretically as in pure maths. Uh, so by 1, you get sine 2 alpha equals. We are going to replace this by sine beta. If you write sine 2 alpha equals sine beta, and you are asked to find values of alpha, possible values of alpha, so in pure maths, we write the general solution of this, and you get an infinite number of answers, infinite number of solutions for alpha, right? Sine 2 alpha equals sine beta, a trigonometric equation. Solving this, you get an infinite number of values. That means alpha. So, for instance, if uh, one solution is 30 degrees, or 30 degrees, 150 degrees, then 330, 390 degrees, the 150 plus 360, but yeah, 750. So you get more and more, an infinite number of solutions. Maybe minus maybe 200 and here 40, minus 200 and minus 300. Infinite number of solutions if you try to solve it theoretically. But practically, this alpha cannot be the outside 0 and 90. This alpha has to fall between 0 and 90. So sine 2 alpha once can be equal to sine beta. That's only because it's 2 alpha. 2 alpha can be between 0 and 180, right? Alpha has to be between 0 and 90. 2 alpha has to be between 0 and 180. So there are only two possibilities if you find the solution of this equation. One is sine 2 alpha can be equal to beta. 2 alpha can be equal to beta, sine 2 alpha equals sine beta, or the other is sine 2 alpha can be equal to sine pi minus beta. You can reject all the other theoretical solutions, right? So, two possibilities, this O sine 2 alpha equals sine 2 beta. So, you get two solutions for this for alpha, 2 alpha plus 2 alpha equals beta O, 2 alpha equals, sorry, this has to be pi minus beta, right? Pi minus beta. So sine 2 alpha equals pi minus beta. So dividing by 2, you get alpha equals beta over 2 or alpha equals pi by 2 minus beta over 2. So you get two distinct solutions. Hmm? Two distinct solutions. Shall we name them? Alpha 1 and alpha 2. So alpha 1 equals beta 2, beta over 2, or alpha 2 equals pi by 2 minus beta over 2. Hmm? Uh, let the two angles be alpha 1 and alpha 2. So you get, therefore, you get alpha 1 equals beta over 2 and alpha 2 equals pi by 2 minus beta over 2. So two distinct solutions, right? That means there are two angles at which you can project the particle to reach the same destination, right? Uh, Further, so this is the first answer. So alpha has two distinct values. Therefore, alpha has two distinct values. Then, then two distinct values. Then you are asked to show that two angles are uh, complementary. Complementary means the addition should be equal to 90 degrees. Alpha 1 to alpha 2. These two angles are complementary. Read the question. That's another part in which you have to show two angles are complementary. It's very easy to do. You just add them. Just add them. 1 plus 2 say, gives addition of them. Alpha 1 plus alpha 2 is equal to pi by 2. So two angles are alpha 1, alpha 2 are complementary angles. So that's also an answer. This is an answer. Further, එතකොට මොකද වෙන්නේ? Right? Two angles are complementary. That means, uh, for instance, if you project a particle at on 20 degrees, give some speed at 20 degrees with the horizontal, it will fall at some point. You project at 70 degrees again, once at 20 degrees, then you project it at 70 degrees. It will take some different path, but will reach the same destination. Hmm? So 20 degrees and 70 degrees. The particle will fall at the same point. Hmm? Alpha of 90 minus alpha, you get the same result. But anyway, මේ ටික ලියාගන්න. තා පොඩි පාඩයක් තියෙනවා ගානේ. ඒක මම ඔයගොල්ලන්ට දෙන්න කරන්න. ඒක මට පොඩ්ඩක් දෙන්න පුළුවන්. මොකද මම පොරොන්දු වෙලා තියෙනවා මේ මොනවාද අද අර Thursday class එකේ ළමයින්ට vector product මට කරන්න අමතක කරලා තියෙනවා. මම vector product කියන එක ටක් ගාලා කරලා දාන්න ඕනේ. මේක ලියාගන්න. විනාඩි 10 15 කරන් vector product එක මම මේකම කරනවා අද. ඔක ලියාගන්නකෝ. If you go and show this result, that means you project at some angle alpha, the particle falls at some point, then you project at 90 minus alpha, the particle will reach the same point. You reach the same point, same speed, but two different angles, alpha and pi by 2 minus alpha. It will reach the same point, but the thing is two different paths, right? So the time intervals, the flying times are not necessarily the same. Say from T1 for this part 1, it can be some T2, other T2 for the second part. ඔක ලියා ගන්න කොයිද? ඊළඟට තව පාර්ට් එකක් තියෙන ප්‍රශ්නේ ඒක මම ඔයගොල්ලන්ට homework කරලා දෙනවා. You show that ගානේ දීලා ඇත්තේ show that if this is R, T1 T2 equals 2ROG. මේක homework කරලා කරන්න. ඔය ටික ලියන්න මම දැන් මේ පොඩ්ඩක් මේක ලියා ගන්න මම මොනවද vector product එක මම දැන් කියලා දෙන්න. හරි? ඒක යන්න ඕන. Dynamics පොතට නෙමෙයි statistics පොතට. Statics පොතට. ඔතන නිකන් ලියා ගන්න ළමයි. homework. මම දැන් ටියුට් එක එව්වා. දැන් ටියුට් එකට කලින් මම ටියුට් එක දැම්මමයි accept කරලා ඇති. Homework වලට කරන් ටියුට් එක first you have to complete this question, this sum, and then you have to do from the tute 5, 6, 7, 8. ඔය ටික හරිද ළමයි? අපි අර වෙක්ටර්ස් පාඩමේ මොනවද? cross product එක කරමු. හරි අපි වෙක්ටර්ස් පාඩම ඉතිරි කරමු. අන්තිම topic එක. We should come go to your statics book. ඊළඟ ක්ලාස් එකේ තමයි කරන්නේ කිව්වේ මට මතකයි දීදාර්මයින්ට මේක කියලා දුන්නා. ඒ වුණාට කමක් නැහැ. ආයෙ චුට්ටක් බලාගන්න. විනාඩි 10ක් කියන්නේ මම මේක ටිකක් කියලා දෙන්නම්. vectors cross product. Right. Before coming to cross product, we did the dot product in vectors. Dot product of two vectors. Dot product we define as given two vectors A and B with some angle as theta between them. The dot product we define as mod of A dot B of two vectors equals mod of A, mod of B cos theta. A dot B equals mod of A, mod of B cos theta, and the result is a scalar. All these are scalars. The dot product gives a scalar. We have discussed this in detail. Now, coming to the cross product of two vectors. There again we consider two vectors like this. in some plane, consider two vectors A and B in some plane with the angle between them equals theta, in some plane alpha, with the plane alpha. So consider two vectors A comma B in some plane alpha. We are going to now define the cross product. The cross product of them of A comma B, it is denoted by A cross B. The dot product is denoted by A dot B, right? The cross product is denoted by A cross B, and is defined by A cross B. This is the definition. A cross B is equal to, for the dot product, it is mod of A mod of B cos theta. For the cross product, it is mod of A mod of B. They are there. Instead of cos theta, for the cross product, it is sin theta. Sin theta, and in addition to this, there is some unit vector n. Unit vector n. So we will explain it. What is this n? Mod of A mod of B sin theta into n. So this is the definition of the cross product. So what is this n? Where n is the unit vector perpendicular to the plane alpha, a normal unit vector, plane alpha. So when you say perpendicular to the plane alpha, perpendicular to the plane, this is the plane containing plane alpha, containing A and B. Perpendicular to the plane alpha, it has to be, if this is the OXY plane, it has to be along the Z axis. So it can be either coming out or going in. There are two possibilities. When you say it's perpendicular to the vector, the plane alpha, there are two possibilities. It can be coming out or going in, right? Now, which is exactly is the direction for A cross B, whether it is coming out or going in. How to determine that? So it is determined by the right hand Ampere's right hand rule. It's for A cross B. A cross B, you have to find the direction of A cross B. You use the right hand rule, not the Fleming's one, the Maxwell's one. You turn your hand from A to B, right? Not B to A. If it is A cross B, turn your right hand from A to B, then it's the direction of the thumb. Direction of the thumb gives the direction of this vector n. So these two vectors in my diagram, A cross B, the direction is this. Its direction is coming out, right? So it will look like this, coming out. So this particular diagram I have drawn, it will be coming out, like this, right? N is a unit vector perpendicular to the plane of which The exact direction is given by amperes. Right hand rule. Amperes right hand rule. Right? Whether it is coming out or going in, you can determine using the right hand rule. For this diagram, for A cross B, you see that using the right hand rule, A cross B, if it is N is coming out of the plane. If you take B cross A, not this, B cross A, then you will have to turn your hand from B to A. Turning from B to A, then it will be going in. So the direction of B cross A is right opposite to the direction of A cross B. So they are not equal, right? A cross B and B cross A are not equal. They are in right opposite directions. Note that A cross B and B cross A are of opposite directions. So they are not equal. A cross B is not equal to B cross A. Now, अब एक दे क्या नहीं थी magnitude direction है क्या ना magnitude वाले so magnitude of A cross B. So A cross B is equal to this mod of A mod of B sin theta into N sin theta into N. N gives the direction a unit vector. N is a unit vector. So magnitude of A cross B is the rest. Mod of A mod of B sin theta. This is a scalar into N. So this scale is the magnitude. So magnitude of A cross B. මේවා තමයි අපි පාවිච්චි කරේ මොනවද to define the අපි අනිත් පන්තිය කරානේ in systems of forces to define moment of a force. We use cross product. මෙන්න මේ ටික තමයි පාවිච්චි කරේ තමයි. So A cross B, mod of A cross B is equal to mod of A mod of B sin theta. අපි ඕක පාවිච්චි කරා, right? In moment of a force and direction. වැඩි විස්තර ඕනේ නැහැ මේ definition එක විතරයි තියෙන්නේ syllabus එකේ. So direction is given by direction is the direction of n. So A cross B is parallel to n. Direction is the direction of n, which is given by the right hand rule. Enter. And n is which is given by the right hand rule. හරි ඔච්චරයි ඔය ඩෙෆිනිෂන් එක විතරයි ඕනේ කරන්න. හරිද? ක්‍රොස් ප්‍රොඩක්ට් ඔක ලියාගත්තා නම් ඇති. ඕක ලියාගත්තා නම් ඇති ඕගොල්ලෝ වෙක්ටර්ස් නෝට් එකේ අන්තිමට මම විනාඩි 5ක් දෙන්න ඕන ලියාගන්න. දැන්ට ඕන කොල කැල්ල වෙන කඩදාසි එකකට ලියන්න පස්සේ එන්ටර් කරගන්න. පොත හොයාගන්න දැන් අමාරුයි නේ වෙක්ටර්ස් පොත. දැන්ට මොකක් හරි ලියන්න නැත්නම් මම මෙතනින් ක්ලෝස් කරලා දාන්න තමයි. ඕගොල්ලෝ ආපහු රැට හරි බලලා ඇදලා අල්ල අන්තිමට බලන්න පුළුවන් නේද? දැන් පොත හොයාගෙන එනකන් මම බලන් ඉන්න එක තේරුම් නැති වෙයි. වෙක්ටර්ස් පොත හොයාගෙන ස්ටැටික්ස් පොත හොයාගෙන වෙක්ටර්ස් වල අන්තිමට මේක දාගන්න. හරි? එහෙනම් අදට අපි මෙතනින් නවතිනවා. for homework මම ටියුට් එක වෙලා ඇති. for homework tutorial questions 1 to 4 like the things very much similar to the things we have done so far. So you don't need to do them again. කැමැත්තක් තියෙනවා නම් කරන්න. But for this week homework tutorial questions from 5 to 8, 5, 6, 7, 8. හරි? ඒ ටික කරලා තියන්න. අපි අනිත් දවසේ දැන් බේසික්ස් ඉවරයි ආ ප්‍රොජෙක්ටයිල්ස් වල තියරි ඉවරයි. අනිත් දවසේ ඉඳන් ඔය ගණන් හදනවා. පුළුවන් තරම් ගණන් හදන එක තමයි කරන්නේ. හරි? එහෙනම් ළමයි ලබන සතියේ ඉරිදා උදේ 10ට හම්බෙමු. ආ ඊට කලින් ඔයගොල්ලෝ තර්ස්ඩේ හම්බෙනවන්නේ. එතකොට ඔයගොල්ලන්ට උසන්නයි.